Okay, super. Welcome, everyone. Thanks for coming to our inaugural Confidential Computing Summit. Joining me shortly on the stage will be Teresa Tung, who's a CTO at CloudFirst Accenture. But before that, once again, thanks to all our sponsors for making this a very successful event. We have everyone who's in the community in this room. We also have representation from academia and a very exciting slew of talks lined for the day. And agree with Vikas completely, the future is indeed confidential. And in no small part because of all the innovation that's been happening across the stack in the last few years. We've seen innovation at the hardware level, from Intel, ARM, NVIDIA around enclaves, confidential VMs. Super excited about the upcoming confidential GPUs as well, which will extend the capabilities of confidential computing to AI and machine learning workloads in a very scalable way. All the wonderful work that the infrastructure and cloud service providers have been doing in making this technology easily available and democratizing it to some extent. Because now using confidential computing and harnessing its capabilities is as easy as spinning up a virtual machine on the cloud. As a result of that, software vendors like ourselves and open source projects can harness the capabilities of confidential computing to bring catered solutions to the market and address the needs of use cases and verticals across industry. The Confidential Computing Consortium has a lot of open source projects in this space too. Opaque provides multi-party collaboration, and our beginnings actually are also rooted in open source. We started off as a humble open source project at the Rice Lab in UC Berkeley with a simple mission. Our mission was to enable organizations to collaborate on confidential data without violating its confidentiality. Banks can collaborate towards identifying financial criminals, money launderers, human traffickers. Healthcare institutions can collaborate to perform better healthcare analytics, build better disease prediction models. COVID is a very good example of that, right? If there's one thing we learned during COVID, is that contact tracing could have helped solve the problem to a large extent. But when we tried to deploy contact tracing solutions, we realized we needed to be able to combine data from various health repositories. And the moment we tried to do that, data privacy concerns came to the forefront, thwarting those efforts to a large extent. Not to get ahead of ourselves, but had solutions like that enable multi-party collaboration in a scalable way been around, then maybe we could have made a huge dent into the problem. To solve this need, we built MC2, a platform to enable multiple parties to collaborate for analytics and AI. And that platform now powers our zero trust data clean room environment. Thanks a lot, Vikas, for defining the term zero trust. But to me, zero trust is almost, you can't have zero trust without confidential computing. Because without confidential computing, you are leaving data exposed at a key part in its life cycle, when the data is actually being processed. So when I hear zero trust in the absence of confidential computing, it almost seems marketing speak to me, because it's not really zero trust if you don't have confidential computing. But in addition to confidential computing, you do need capabilities around governance, auditability, verifiability, all the ingredients that Vikas listed. And really that goes into our data clean room product that enables multiple parties to collaborate for a variety of use cases. But as is the theme of the day, what I'm excited about in terms of what's next and what I want to show you a preview about is generative AI. In the last few months, we've seen an explosion in AI, in the adoption of LLMs. They're being used for mundane tasks such as composing emails to more important activities, building applications for servicing customers. Every organization is now looking at harnessing the power of generative AI to solve business needs. But data privacy is a very, very key concern that has emerged in this space, and that is slowing the adoption of LLMs and generative AI. Italy banned ChatGPT for a while because of data privacy concerns. We know what happened with Samsung. So every organization wants to harness these capabilities, but at the same time, they need to be able to protect their PII information, their financial data, their healthcare data also IP. And IP goes both ways. Organizations have their data, which they want to protect, but model providers who are building these foundation models also want to keep models private when enabling these capabilities for organizations. So there's privacy across the spectrum that is needed to be able to fully realize, but perhaps, the potential of generative AI and LLMs. Let's take an example, right? An example of what's needed. This is a fictional cola company that wants to use generative models to improve their business processes and workflows. They have proprietary information, the secret ingredients or recipe that goes into their cola, and they want to ask the model to be able to answer questions on that data. This information is proprietary to the company, and the results produced by the model in this case are also proprietary, because this will go into informing the company's business decisions. Vanilla adoption of LLMs and generative AI puts both of these at risk, because your data and queries are exposed to the service or the model provider. The results are also exposed to the service and the model provider. What you need is the ability to be able to encrypt your data and queries, keep the results encrypted as well, and keep the processing protected and encrypted as well. And confidential computing can provide a solution for that. Another example, and this is an actual prompt that we fed into OpenAI, into ChatGPT. A question like, to whom does this particular SSN belong? Does it belong to a person called Adam Smith? And this is a question that you could be asking based on your own data that you want the model to answer. Right now, OpenAI returns this response saying that, please don't input SSNs. This is against our policy. We don't want to assist you in any activities that lead to identity theft, etc. But the point is that this data has already been exposed to the model provider, OpenAI in this particular case. OpenAI detects that this contains PII, but it already has access to this information. And this is a problem, because ideally, you want to go beyond contractually enforced trust, which you are limited to in this case. They enforce their policies and business workflows that that control them from retaining data, etc. But you want to move from contractually enforced trust to technologically assured trust. And this is really what confidential computing can enable. So what we need is a solution that enables privacy-preserving LLMs, where your data that you provide, the data and the queries that you ask of the model are encrypted. The queries are processed in a secure, confidential computing environment, such that they're not exposed to anyone, not even the model or service provider. The results that are produced are also encrypted before being sent back to the customer organization or the user. And this can happen in iterative fashion, depending on the application that you want to use it for. So this is something that we at Opaque are super excited about. And we think this is a necessary application for generative AI and LLMs. And as part of that, I wanted to show you a preview today of what's coming. And in that preview, what you'll see is essentially a collaboration, a privacy-preserving collaboration between the model owner, the entities that are training these models and providing these models to customer organizations. We will have a pre-trained LLM running inside confidential VMs within Opaque's confidential AI platform. And the queries that will be served against this model will also be encrypted, and the data will also be protected, so that the model owner gets to see nothing. They protect their IP, the user can protect their queries and data as well. Before going into it, at a high level, how this works is as follows. And this is a high-level architecture of what the system looks like. You have a trusted on-prem client component that is responsible for verifying and attesting the server-side Opaque deployment, making sure that everything is set up correctly, that the model is authentic, and everything is running securely within confidential computing technology. This runs on a cluster of machines, a cluster of confidential VMs in the cloud. There is secure communication between them as well. all using attested TLS. So this ensures the end-to-end security of data and queries throughout its lifecycle. So let's take a quick look of what that means in practice. So what you're seeing here is essentially a simple chatbot that we built. And this chatbot is basically interfacing with the on-prem client. Let me increase the size a little bit. OK. So if you, as an organization, want to make use of an LLM model that's running in Opaque in a cloud, the first thing you would do is establish a secure connection with the Opaque service. This process will attest the deployment on the cloud. It will establish keys for the user that is running the queries and analysis, and make sure that that secure channels of communication are established between the client and the server. Once you've established that connection, you can provide private context to the model, using which the model will respond to your queries. So in this case, the context is some private health information about a person called Andre Yetz. And there is a doctor who wants to use this information to answer questions. He wants to use the model to answer questions about this person as they interact with it. But this is, of course, a very sensitive, protected health information. So the health organization needs to ensure that this remains concealed and private from the model provider at all times. So before providing the model with the context, the user can encrypt the context and submit it to the model. And all future queries that are answered will use this private context to answer those queries. Now, once the model has the context, I can engage with it. I'm a doctor. I want to ask the model, when was Mr. Yetz's last physical? Right. This is my query. I want to keep the query protected as well, so I encrypt it. I submit the query to the model. The model takes some time. It returns the results. The results are also encrypted. And then I can decrypt the results locally and get the answer that I want. And throughout this process, the query remains private, the context remains private, and the results remain private as well. I can continue the conversation. I can ask the model, how old is he? And the model will, once again, take in the encrypted query, run the analysis, run the predictions, return the results, and give me back the response. The person is 42 years old. This particular model spits out some additional information. So depending on what the model is, the answer may differ. In this case, we use an open source model called Girdle. Finally, I can ask the model further private questions. What is his SSN? Again, very secret information. Encrypt it, submit it. The model will take some time to produce the results, and I can decrypt it, and it gives me the right response. But essentially, this hopefully illustrates the power of confidential computing and what it can do to facilitate the adoption of LLMs and generative AI in a privacy-first way. And the solution that we are building, that I showed you a preview of, will hopefully go a long way towards that. So super excited about it. So coming back to why this is useful, I think we all understand this by now, but there are benefits across the value chain for adopters of this technology, right? For service providers, they can provide technologically assured trust to their customers. You don't have to rely on us to enforce policies through a piece of paper. Here is a technologically assured guarantee that even we can't see your data anymore. For model owners, for organizations that are building their own models, they can keep those models private without having to worry about leaking or revealing IP to their competitors. Data owners can keep their PII protected and encrypted at all times. Also facilitate governance to comply with regulations or their internal policies around how data might be protected. And finally, for end users, they get the assurance that their data will not be misused, that the results that they are getting will not be tampered with, and overall further their privacy concerns. these technologies get adopted. So summarizing Opaque. So Opaque, we provide a platform for zero trust data clean rooms. This enables secure data sharing and analytics. It also provides privacy and compliance. We have also made further advances in multi-party analytics, making our product easy to use for data scientists, as well as data analysts and business users, with fine-grained controls for setting policies and enabling governance. And finally, what we saw in preview today, privacy-preserving LLMs, something we're super, super excited about. So all of this is possible because of our platform that is built on 3 key principles: make it super easy to use and frictionless for end users, enable security from the get-go using confidential computing and the software ecosystem around confidential computing, and finally, making it possible for these solutions to be scalable. Because without scalability, you will not be able to harness the full power of big data and large language models. So without further ado, please join me in welcoming Teresa Tung to the stage to talk about some of the work that we are doing together. Thank you, Teresa.